We want to fill in the table with the missing function values, then determine if the table models a linear function or an exponential function, where function values with a pattern of repeated addition represent a linear function, and function values with a pattern of repeated multiplication represent an exponential function. Notice for each table, the inputs or x values are in the first row, and the outputs or function values are in the second row. So looking at the first table, notice how the inputs or x values are increasing by 1 each time. Let's see if we can recognize a pattern in the function values. The function values go from 2 to 4 to 6. Notice how the function values are increasing by 2 each time, and therefore the pattern is repeated addition. 2 plus 2 is equal to 4. 4 plus 2 is equal to 6. And now we can find the missing function values by continuing the pattern. 6 plus 2 is equal to 8. 8 plus 2 is equal to 10. So because the pattern is repeated addition, we now know f of x is a linear function. We can also say that f of x increases by 2 each time the input or x value increases by 1. Now looking at the next table, again notice how the inputs or x values increase by 1, and now let's analyze the function values to determine the pattern. The function values go from 2 to 4, but then 4 to 8. So notice how in this case, we do not have the pattern of repeated addition because 2 plus 2 is equal to 4, but 4 plus 2 is not equal to 8. But 2 times 2 is equal to 4, and 4 times 2 is equal to 8, and therefore the pattern is repeated multiplication. Now that we know the pattern, we can determine the missing function values. 8 times 2 is equal to 16. 16 times 2 is equal to 32. So because the pattern is repeated multiplication, we now know the second table, or g of x, is an exponential function. We can say that f of x is multiplied by 2 each time the input or x value increases by 1. Before we go, let's look at this graphically by plotting several points of f of x and g of x on the same coordinate plane, and then sketching a graph for both f of x and g of x. So if we were to plot the first 4 points in the table for f of x, it would be these 4 points here. Notice how if we connect the points, the graph is a line, which verifies f of x is a linear function. And if we graph the first 3 points of g of x from the table, it would be these 3 points here. And if we connect those 3 points, it forms a curve. An exponential function will always be a curve and not a line. I hope you found this helpful.